Hey everyone, thank you for coming this afternoon. I guess we're just gone halfway through our conference. I'm Denham-Parry, so today I'm going to be talking to you about scaling microservices with message queues, .NET Core, and Kubernetes. So if you want to contact me, I'd recommend using Twitter. You can message me on there, or just grab me after here, or I'll be here all week. So NDC means so much to me. It was the first conference I went to. I gave a lightning talk yesterday about it, and it helped me find my love of development again. So it's amazing that I'm here today. I'm so happy to be here, and I really hope that I can share with you some of the things that I've learned in the last couple of years, as well as the other speakers have given to me. And on that note, there's a couple of speakers who I really admire for making people aware of issues within our industry. So just to start, mental health. I suffered from depression, and I'm still trying to manage it occasionally. But equally, coming to conferences, it kind of can be a big, daunting thing. So if you do need to talk to someone, because a lot of people have helped me out by being able to talk to them, if you need some help, just, again, give me a shout. So on that note as well, please take photos, because like I've said, it's a 6-track conference, 3 days. You're going to learn so much. If there's things that interest you, please take photos to remember. So yeah, I work for this company now, Learn Kubernetes. So I've now become a trainer. So we do 2- or 3-day workshops in the public and private sector. And 2 years ago, I wouldn't have thought that I would be in that space, but that's where I've ended up. Because originally, I was a .NET developer through and through. I've been contracting for about 10 years now within the industry. And then I fell in love with .NET Core. I had a MacBook with, I called it Windows in disguise, because the business I was in, they said, you need to have a MacBook. And so I just got Parallels, and I put Windows in there to feel safe again. But then I started using .NET Core to see how I could use my MacBook. So on that as well, the layout of this talk is going to be a little bit different. So I'm just going to give some tips, because these are my tips. So I'd like to call them off-the-record tips, because no one's going to hear this after this, so it's OK. This isn't anything associated with Learn Kubernetes. This is how I've got to a stage where I could start training. So first of all, just containers. This is where it all starts. We're going to be talking about an orchestrator today, Kubernetes, but I became interested in containers because of the way that we can use them to manage our work. I got so fed up of having to find a way to deploy something that hadn't been deployed for the last 3 months, and then the person who deployed it last, they left the business 2 months ago, and I didn't know what I was going to do. So I was looking towards containers just to have this kind of state that I could work with. So I went to a well-known search engine, and then I started looking, and I was like, containers, Docker, what's this? And it all just ended up being on Linux. And it's like, no, I'm Windows, I don't know that, not interested. But then I found this. So Elton Stoneman, he's got a book called Docker on Windows. This is a book. I've read this within 2 days, and then it got me up to speed straight away. So this is all Windows-based. They take, Scott Hanselman had an MVC project in 2011 called Nerd Dinner. And so they put that into a container, and it's about 4 gig in size, which isn't ideal, but then they use a strangler pattern to be able to take things apart. So on that point as well, Elton's going to be here tomorrow, and he's going to be talking about what is a service mesh. That's in room 5. So I also run a meetup in Wales called Cloud Native Wales, and I run it with Salman, who's here today, and also a chap called Alid. So for Halloween last year, this was his idea of a service mesh. So hopefully you'll be able to learn a little bit more as to what it is tomorrow. So the other thing I just want to make people aware of is Microsoft love Linux. So within Kubernetes, Microsoft are helping out so much on the Linux side. So they've got a chap called Brendan Burns, who was one of the founders of Kubernetes, is now with Microsoft. There's a huge team there. And they also offer things such as Helm and Draft to the CNCF, which we'll come to in a moment. But I want it now. I get it. If you're on Windows and Kubernetes it's the next thing, I get it, you want it now. Now, I'm not comfortable enough to come on stage and show you Kubernetes on Windows and be confident enough to give you a live demo and it all working, because I've got enough pain in my life. But later on, I'll show you a couple of diagrams, and I can show you how we can actually process some window workloads within containers at the moment within Kubernetes. So, and this chap, Sam Newman, great guy, and yeah, you don't have to run Kubernetes. So always think of that as well. I'm not going to have arguments about you should be using Kubernetes. Everyone's different. It's fine. It's just nice to know what the options are available. So yeah, I've also been quite ill today. So I only just got out of my hotel room 10 minutes ago. My voice is usually a little bit higher than this. And so I don't know if this has happened already in Conference Bingo, but has anyone had a container slide yet? Has anyone seen one this week? Cool, okay, you can take that off a card. We've done that one, that's cool. So this is what containers is shown as, and it's been shown for a while, and people are saying they're bored of this. So I got a different idea as to what a container is for me. So does anyone watch Rick and Morty here? Can I see it? Oh, we got some hands. Yes, we got hands. We got participation. That's it. So this is what I think containers are more like. So does anyone know who this is? I think I heard someone say music. Yeah, yeah, well, yes. So what happens is that when they have a job to do, they press a button, he appears, he'll do the job, and then he dies. Just does one job. Now, with spoiler alerts, when they try to do multiple jobs, it all goes to chaos. It's the same with containers. Just focus on simple things and doing them quickly and right. So CNCF, it's Cloud Native Computing Foundation. They're an open source organization, and if you look here at the landscape, l.cncf.io, they'll show you everything that's available, so all the projects that are open sourced there. So I know there's just so much stuff, but it's a really useful tool, because when you hear buzzwords, sorry, not buzzwords, I should not say buzzwords. When you hear products and you're just trying to understand what they are and do you need them, do you require them, are there any other alternatives? This is a great resource so that you can click on Helm, then you can see other options other than Helm. So I definitely recommend that. They also have this trail map. So this trail map is really good at understanding how to become cloud native. So the idea is that you start on point 1 and you work your way down the trail. So at point 1, we do have a containerization. There we go. There. So containerization. So again, this is a key point. Just do containers right, and then also set up a CI/CD pipeline as well, so that we can automate builds, and then you can look towards orchestrators. Another tip is learn back. So there's a great resource by a chap called Ben Hall called Catacoda. So most of the things that you see within CNCF, you're probably going to find on Catacoda as well. So he spins up VMs in the cloud somewhere else, and it allows you to jump in your browser without having to install any dependencies. And then you can start playing with products. And that's the concept of learn back. Instead of having to learn and install everything, and then just hit all the bugs and everything else, it'll give you a scenario where you can build something, and then you can work your way back from it. So my last tip as well is just learn simple things the hard way. I went in at a high level, and then I had to keep knocking back down a level. So on that point, there's this chap, Emil, I think, and he's got a book called Learn Bash the Hard Way. He recommended to use this URL to purchase it if you're interested. And it's a great, so I used to commute to Bristol every day, and so I had an hour on the train. And so I could do this all on my laptop without an internet connection. And it allowed me, I can do so many more things now that I wasn't aware of before. I was a great dev. Oh, whoa. Oh, I should not say I was a great dev. There's some people in the room that know that that's a lie. But I was good at certain things, and then I was terrified to have to learn back and go and learn another stack. I've always been scared to go to Java, because I'm like, well, I'm Microsoft. I know this. This is my domain. But I've actually found out that if you learn stuff, it's actually kind of similar everywhere else. If you're here, I'm sure you've got quite a good ability. So it's really interesting when you find out how to do it. Well, I find it interesting anyway with other technologies. So that's the cover of the book. So I will stop giving tips now. I just wanted to give that because that's the stuff I wish I heard on day 1 when I started my Kubernetes adventure. So now we're going to go into the slides. So I'm going to talk a little bit about Kubernetes and scalability and why it's of interest to us. After that, we're going to have a little bit of a demo. So again, there might be some audience participation, but I'm going to try and, yeah. Oh, and actually this demo, I just ran it half an hour ago to film it, because if it goes wrong, I can show you the video. And the video went wrong. And that's a cluster I'm going to be using. So sit tight, because I don't know what's going to happen. So scalability and robustness, here we go. So in life, we like to purchase things. So all of a sudden, the new product comes out. And what happens next is that it becomes available at 5 p.m. or 6 p.m. And so throughout the day, we don't have any traffic, and then we get a huge spike there. So how do you deal with so much traffic? So we have a back end and a front end. So the backend is usually our REST API, and then we'd have different things. So we'd have browsers, and we'd have other devices, and they could connect to our backend API. So planning for launch, so I'd like to introduce you to Chris and his cat to Dan. So what would happen is that there's our front-end web application and our back-end API. And what we've said is that actually we want to have 4 back-end APIs. So to do that, we need to be able to network between them. So we had put something in place that we'd call a load balancer. Now, we'd also do the same thing on our front end so that we can have multiple instances of our front end and back end running, and we don't have to worry about where the traffic is being directed to. So performance tests. Let's have a quick go at our performance test. So our front end application is stateless, and we have a limit of 1,000 requests a second. Our back end is stateless, and it also has a limit of 250 requests per second. So it's a ratio of 1 to 4. So let's get ready for this. So let's think again. Let's think of the favorite thing that you want to purchase next. It's become available at 6 p.m. Or actually, say that you're in the office and you're the one who's trying to manage this. So what we've got is that we've got 4 front ends and 4 back ends. Now, that's not ideal already, because we know that the front end can handle 1,000 each, but the back end can only handle 250 each. So when traffic starts to overload some of the back ends, they start going offline. And when they go offline, it's not really helping the issue by just sending everything else to the other ones. And they're just like, well, I got too much to do, it's not going to work. And then it just all goes. But then what you do is that you hear someone up in the business call you directly and say, the site's down, everything's crashing. So you just say, I'll add some more, I'll add some more. So you add 4 more, and then everything comes back up online. But the issue is that's too little, too late. We've had to have a manual intervention to be able to do that. So, and now we've just missed the peak demand of it as well. So we've missed a great opportunity. So let's have a look at this case then, where we don't just have one Chris, but we have multiple Chris's and Dans. And actually, the websites just can't handle it. There's too much traffic. And then all of a sudden, everything just starts crashing. And then at that point, it's game over, man. Game over. It doesn't matter. So I'm sure you're thinking, that's a nice story, Lewis, but how do we know? We know how to do scaling. And so I think someone said that, and it might be from some organization, but maybe like this organization, so does everyone know when Prime Day is, or is no roundabouts? So you'd kind of think that the infrastructure would be ready. Well, the only thing that was scaling here was just for news articles. There's just lots more news articles becoming available saying that they can't rescale. So their report was the retailer didn't have enough servers to handle the traffic source for the day. And Amazon had to manually add servers to address the issue and failed to add them fast enough. So how could we improve this? Or what could you improve? So we could have automatic scaling. Could we also have decoupling of scaling? So in this example, we've got a ratio of 1 to 4. So we've got 2 front-end web apps, and we've got for each we've got 8 back-ends. So it's a 1 to 4 ratio. So if we increase it, then can we auto-scale that to keep the ratio to 1 to 4? And then if we actually say to ourselves we're using up too much resource, we could say we want to have it as a 1 to 2 ratio, and then it will update automatically. Can we also decouple our failures? So here's our user again, and we've got a document that we've put into the system, and then it gets processed somewhere in the back end, and it's all done. Great, good job. But what happens when we don't have a back end? The document just stays there, or does it just collect at that point? So what if we just had a message broker there? So the user that we have goes to the website and then sends a couple of messages to us, and in turn, they get sent to the message queue. And then when it's available, the backend can pick it up and process accordingly. So scale independently, we've done it. So we can now say that we've got 4 fronts and 4 back, and then we can scale to 1. It's great. We can handle, and we can also now handle failures. So if the backend isn't available, then yeah, it'll just stay in a message queue. So what about automatic scaling? So this is where the orchestrators come into play. So Kubernetes isn't the only one. There's a couple available, but as you might have seen, with the title of this talk is about Kubernetes. So yeah, we're just going to talk about Kubernetes today. So It's open source, it's multi-cloud, and it's designed to scale. So does this help with what we're trying to achieve? So we can scale independently, we can handle the failures, and we have automatic scaling. So that sounds like a plan to me. So, especially for NDC, because I know I felt like I need to up my game as this is my first time here. I thought I'd build a demo especially for NDC London. So this is the app that I've created. Now, look at my design skills. It is our front-end web application. It's minimalistic, it's beautiful, and it's welcoming. So what would happen is that the user would click Get Ticket, and they get redirected to this processing screen. So this processing screen is connecting via SignalR and listening for broadcast messages to a group. The group ID is generated by a MongoDB in the backend, and then we have a worker role, which when it picks it up, it will send a message to the group to say that it's completed the job, and then it will redirect that user to a video of people clapping, because I understand it's in the afternoon and you don't want to clap, so I thought I'd get your phones to do it for me. So let's just talk about containers again for a sec. So container is essentially, so we got .NET Core in there, then we might have our app settings, and then we can have whatever else. We can have a cat in there if we want, because all I'm really concerned about is a container on the outside. I'm just concerned about the interface that I'm connecting with. So deploying apps in Kubernetes. So here's our front-end, back-end, and so on top of that, we put our load balancers. And also, in my demo, I'm using RabbitMQ as my message broker. And then I've also got a worker, which I've assigned to an autoscaling group. So here we go. Kubernetes likes to name things differently. So instead of calling them load balancers, we call them services. And we create a service for each pod that we want. So I just mentioned pod. Now, we don't call them containers. We call them pods. Now, what's the difference between a pod and container? A pod can have multiple containers. I hope to give you an example as to why you might want to do that, but it's usually common just to have a one-to-one relationship. And then we have a horizontal pod autoscaler as well. That's what we're going to use today, is HPA, also a name of my favorite beer, but yeah, horizontal pod autoscaling. So lessons learned, scaling in Kubernetes. Can I just get a show of hands just for who knows about Kubernetes? Or, okay, cool, that's about half the room, great. So for people who don't necessarily know about Kubernetes, so what we call our machines, we call them nodes. So this could be a physical machine or this could be a virtual machine. So within here, so we've got our Kubernetes layer, a Docker layer, and then we've got a virtual machine available here. So if you had to do this manually, you'd probably say, right, I'm going to put my application. The red one is our web app container, so we're going to put it there. And then, because we know what we're doing, we're going to put another container on another machine so that if one machine fails, we're covered. And we'll keep doing that. And then we'll just keep going up and up until we've used up all our resource. Now, at this point, what would you do? I think I heard someone whisper, add more nodes, which was absolutely correct. Well done. And so then we can start adding more containers onto that too. So you can also think of it as the best Tetris player ever. So I'd also like to introduce you now to the master node. So the master node has got the Kubernetes logo on this at the moment. So the master node is running the show. So here's our favorite container again. And Kubernetes, when we ask Kubernetes to deploy it, then it decides where it needs to go. Now, so far, I've had the same container, shape and size. Now, not all containers are the same. So that's why it's the best Tetris player ever. It can figure out the best places to put it. And Kubernetes is just essentially a REST API. So you can actually access it via Swagger. So, right. Here we go. It's demo time. And I don't know where we're at after running from a hotel. So. One sec whilst I just share my screen. Thank you. Yeah, I lose a lot of time with this. I do apologize for anything that's on my screens in the next moment. I hope I've turned notifications off so that my mum doesn't message me to say good luck. There we go, mirror displays. Took me a while. Great. Oh, demo. Okay, is there a couple of people in here with access to this website at the moment? Cool. So if you've got access to this website, if you could just turn your phone on to, set it to 11, and go to that URL. So I don't have my laptop connected to it, so I'm going to get ticket. Here we go. So we can now see the processing. So, new challenger approaching. That means that the work has come online, then it's processing ticket received. There's some other challenges, so I hope there's some people there. And, oh God, okay. That wasn't clapping, and I don't really want to watch Rainbow Dash right now. So I can't hear anyone else at the moment, but well, this is the issue. Whilst that's happening, I'll show you why. There's one, I hope. Yeah, thank you, thank you, thank you. So, kubectl get pods. Come on, internet. Yes, there we go. So we'll get our deployments. So what we can see here is this, I've still got Grafana. So I've got 10 ticketing webs working. I've got one ticketing worker. I've got one API and the Mongo. Now I can't see where my message queue is. That's a little bit concerning. Anyway, we'll plod on. So there we go. We're getting some more booze. All right, I'll try and improve it. So let's, here's my Kubernetes. So now I said my code isn't necessarily the greatest. So let's have a look. So let's have a look in our worker. So we'll go to our deployment file. So this is YAML. If you're new to YAML, it can be scary, and you can usually say bad things towards it, but you get used to it after a while. So I can see here that I've got a Docker image, so ticketing worker boo. So that might be potentially one of the issues I've got. So what I'm going to do is I'm going to change it to yay, and then I'm going to apply it. So I'm using kubectl. So we got some people here who know Kubernetes. So does anyone call kubectl differently in here? Okay, can stop booing. So we got everyone calls it something different. Actually, sorry, the text is a little bit small. I do apologize. If you can't see it in the back, then please shout at me. I'm here to serve. So what I've done is that I've used kubectl, so that connects to the API. And so what I've done is that I've said to my Kubernetes cluster that, oh, there we go. We got some clapping. So it's because I updated it to kubectl apply ticketing worker deployment. I updated that deployment YAML to go to the ticketing worker yay, which directs you to the clapping. Now, as we've heard, it's happening sporadically, and that's because I've got this issue. So everyone can see that? I've got one ticketing worker here. And like I said, when I mentioned about pods being able to have multiple containers, the 2 of 2 means that I've got 2 containers running within it. Now, within the code base, I've got a console application, which I've left purely as a console app, and then I've also got a simple web app to create a metrics endpoint. So the metrics endpoint is just giving a very simple text file that just says tickets and the number of tickets currently in the queue. Thank you. So, God, this might have been a bad idea. So now, we've seen how we can update on Kubernetes, and I just wanted to show that for people who might not necessarily know Kubernetes and just start to see some coding example. So I think the next place I want to go is to scale up my Kubernetes cluster. So I've got this file, so let's have a look in code for a sec. So within here, I've got ticketing queue, and I've got a HPA. So this is also a YAML file. And I can send as many YAML files as I want to Kubernetes, and they're declarative, so there's lots of different things that can happen. But within this file, the main thing to notice about the HPA is that I've got minimum number of replicas. So that's the minimum number of instances that I want of my worker. So this is declaring that I want 10 workers running at any one time. The maximum number of replicas is 20. Now, do you know why you might want to have maximum number of replicas? Yeah, you've got money, it could be taking up too much resource. Yeah, you've got all those issues. Also, about half an hour ago, you might have just overloaded all your nodes, and everything would have crashed whilst you were doing the video So you knew you had a backup ready just in case. So let's apply this file. And we'll also, whilst we do this, we're going to watch what happens with the pods. So I'm going to apply my ticketing, then we've got Q, and then it's HPA. So let me clear the screen for you, and then kubectl get pods. Now this time I'm going to do it with -w, which means watch. So we can see that it hasn't happened straight away. Usually when you're scaling with Kubernetes, if you scale within your deployment files, you'll apply it and you'll expect to see something to start happening. With HPAs, they're a little bit different. And it's one of these interesting scenarios as to why, one of the negatives of necessarily using a cloud provider. So cloud-hosted Kubernetes means that you don't have to run everything else. Oh, sorry, we can see the workers spinning up now. So the reason I like AKS personally is that I don't pay for my master. So the master is still on a node, which is still a virtual machine or a computer. So it's something I got to pay for. So if you're with someone like Amazon, you're paying for that resource. If you're with Azure, you're not paying for it. Now, one of the issues with it is that with HPA, the amount of times that it tracks, it takes about 3 minutes to update the scaling, and then also, I can't remember. I've got a brain freeze, but when we have a look at scaling, we'll get back to it now. So there we go. So if you have a look at kubectl get pods now, so we can see that we've got a number of ticketing workers running. Now, rather than ask you all just to go onto it, what I'm going to do first is I'm going to do an A/B test. I think that's right. So I'm concurrently sending 15 across up to a count of 500. So whilst that's happening, I'll open up another window just underneath it. God, I've done a load test on conference Wi-Fi. So whilst that's not working, we got 100 requests. Now, sorry, I do apologize for bouncing around a bit, but I mentioned the metrics that we had. So with Kubernetes, there's lots of different ways that we can manage scaling. So like we can see CPU usage and other things like that. But if you want to have a custom metric, then we need to create on an API. So what I can do is I can do kubectl get raw, and then I can ask for the raw. Because it's just an API, I can just ask it there. So if we can see on the bottom, I've got 443 currently in my message queue. So what I'll do again is I'll just check again. Hopefully, so we've gone down to 415. So again, remember that we've got currently 10 workers running, and they're currently processing those leads. Now, within our HPA, I'll just exit here for a sec, and I'll go back to code and have a look at our HPA. You can see here that we've got a target average value of 3, which is ridiculous in comparing to that load. So that's what it's trying to achieve. Now, what I've learned so far with this is that it doubles in size. So that's why I haven't gone and started with 1 worker, because doing this demo here today, it would have taken far too long. So let's have a look on the next point. Let's check this again. Kubectl get raw. Okay, so we're down to 336. So I've been trying to keep you occupied for a moment whilst we've been doing this. So get pods watch. No, so we're still on 10. So like I said about AKS, it's because I don't have, because I can't manage my master, then I don't get to change the settings for the time it takes to refresh these stats. But let's hope that something changes in a couple of minutes. It's always at this point, it's always a little bit nervous as a speaker when you're just like, come on, I've written you, I trust in you. Yeah. Okay. There we go. Hey, oh, thank you. It was never in doubt. I never had that. That never happened. So what's happened in this case is that our HPA has noticed that our average tickets number is too high, so we need to add more workers to it. Now, as we had a min of 10 and a max of 20, if I close this, so a little bit of an easy way to see the number that we got going on is by getting our deployments. So we can now see that we've got, on the bottom here, we've got ticketing worker as 2020, 2020. Great. So let's have a quick look at our queue. So we're down to 137. So whilst that's happening, I'm going to set up a new screen. So I'm going to, I'll create a session. Oh, it's a duplicate session. Yes. So Kubernetes, let's make it a little bit bigger. Let's check the code. So it's cool that I'm just showing you this, well, I think it's cool just showing you this endpoint that's returning me JSON, and I can just say that this is a value that's available. But what would be better is if we could have an actual dashboard. So let's see if we can get that up and running. So if I, cheers, thank you. So, sorry, I'm still not very well. So what I'm going to do is that with this command here, I'm going to, let me just get that set up right. So in the bottom left here, I'm passing this command. So I'm proxying the Prometheus data to my local host 1990. So now, if I go to localhost 1990, I'll be able to see the data coming through. So if I then, because I want to make it look nice, I'm going to go to Grafana. So I'm just going to export this for a sec. There we go. Right. So now when I find one of my many tabs, if I go to localhost 3000, so I'm now able to access Grafana locally by creating a proxy between myself and my cluster. So on my dashboard, I can click New Dashboard, Graph. So I can just simply, these are all the stats that are coming out from Prometheus. So Prometheus scans these, you can set it to how often it scrapes it. So we can see some of the demos there. Again, I can't hide my shame here. I'll be completely honest with you. So this is a moment, I'll have to go to 3 hours, and let me get that. There we go. Right, let's make this easier for everyone to see. So just edit this, and let's get rid of that legend, because we don't need that. We'll maximize it. Cool. So this was the moment, I'll use my clicker. So here's me doing my demo in the hotel room just before coming here. And then here's where it all crashed and it all started going wrong. And then that's when I had the mad dash to here. So we've gone okay so far. So let's just make it a little bit easier to see, and let's change it down to 5 minutes, and we'll send across another load test. So as that load goes across, this is refreshing every 5 seconds, so we should start seeing some traction. So it's starting to spike. Cool. So let's just have a quick look at how many pods we got going. So yes, we're currently running 20 of 20. So we should be able to see this go down. Now that we've warmed up this service, I'd like to ask everyone here to open up their laptops and phones and set them on to as loud as possible. And I really want to try and crash the conference Wi-Fi. So if you wouldn't mind, it would be greatly appreciated. Only because I can't do this at home. And it's... So whilst that's happening, does anyone have any questions they'd like to ask? What's this? This is Grafana. Grafana. The address. Oh, sorry, my bad. Developmentsquad.com. Just HTTPS, developmentsquad.com. So many windows. There we go. So whilst this is happening, I'd also just say that cloud hosting is a great way to get started. I tried to do Kubernetes a hard way by, so there's a talk that I saw here last year by Alex Ellis and Scott Hanselman setting up a Raspberry Pi cluster and hosting Kubernetes on that. So I thought it would be a great way to get started. And it is, and you learn quickly why you'd like to actually give it to someone else to manage. But, all right, cool. Probably shouldn't have done 500, should I? Ah, there we go. We got some coming in. So like we just made this a little bit better than we did at the start of the day when we just had a single worker running this process, and we've been able to manage this scalability without having to do anything else. Thank you, Robin. We've been able to do the scalability without having to intervene because we had the HPA there that was constantly monitoring this. So, final point here. We're just going to update our deployments. So I'm going to go what am I going to do? I'm not in my directory, so I'm going to go there. I'm going to go to code. So has anyone heard of PubConf here? Can I get a yay if you've heard of PubConf? Yay, thank you. So much interaction today. Right, where am I going? So I've also got, we've also got phone calls now as well. So I'm just going to deploy this. Ticketing worker. So let's have a look what's happening. Let me go to another, yeah, that was a little bit easy to see. So we've just set Kubernetes that we want to update an image that's running on the pod so that we can see some of the workers there that they're currently in a state of terminating and pending. So that's because they've become aware that there's a different image that should be hosted. So hopefully, because I've only just done this in the last hour as well, which might be why it failed earlier on. So if you go to ticketing web now, oh no, it's still going to YouTube at the moment. Ah, too much. Let me just, I know what I'll do. I'll make sure of this now. I'll do kubectl delete HPA. So I've deleted that worker, and I'm going to reapply my deployment. Then in doing so, we're almost there, almost. Yes, there we go. We've got some people with it now. So we got Eventbrite. So there's some tickets still left available for PubConf tonight. Oh, sorry, for tomorrow night. I'll be talking about how we're actually living in a zombie apocalypse. The title is Shaun of the Dev. So yeah, I think there's some tickets still available. So if you'd like to come along, it's a great way to meet some amazing people. I'll be there, and so it'd be great to see you there. But on that point, I'd like to ask if there's any questions. Or just creaky floorboards. Cool. Well, thank you for your time and your participation. I hope you enjoy the rest of your conference. Cheers.